Okay, welcome to our first flipped lesson for Stage 1 Chemistry. The idea of these flipped lessons is so you can go through the new content even when I'm either not around or I'm maybe working with another class, and then when we have that face-to-face time or that time during the video conferences, that we can really concentrate on questions and clarifying your understanding and progressing your learning as much as possible that way, rather than just you listening to me during those times. Let's get into it. Okay. Firstly, I'm just bringing up my little laser pointer. Got that working? Yep. So the key things that we need to know are up in this top corner. They're our science understandings. That's what the SACE board tells us that we need to teach and that you need to know in Year 11 Chemistry. So the three things that we're going to focus on with this first lesson is all material consists of atoms, which I suspect you're already familiar with, but we'll explore that in a bit more detail. Atoms are commonly modelled as consisting of electrons orbiting a nucleus containing protons and neutrons, and emission and absorption spectra of the elements provide evidence that electrons are arranged in distinct energy levels and can be used to identify some elements in matter. So that's really here we're going to get into the understanding of how we know about the structure of the atom. Before you start this, and I would have put these links up on Edmodo, I'd strongly encourage you to have a look at these two videos here. They're two TED Ed videos. One is just how small atoms are, and the other is the 2,400 year search for the atom. They're both about 4 or 5 minutes long and give a really good introduction into atomic theory. So if you haven't done that already, pause this one, go and have a look at those videos. If you have already looked at that, let's now talk about the structure of the atom. So as I hope you would all know by now, atoms are made of protons, neutrons and electrons. The protons have a positive charge. They're found in the nucleus, which is the centre of the atom, which I've got here, the centre of the atom called the nucleus. The neutrons have no charge. They're similar in size to a proton. So protons and neutrons are similar in size. They're also found in the nucleus. Electrons have a negative charge. They're much, much, much smaller than a proton or a neutron. They're about 1/2000th the size of a proton. And they're found orbiting the nucleus in these fixed shells, which we've sort of indicated here. The blue dots indicate the electrons, and you can see these electrons are all orbiting in shells. And we're going to talk much more about those shells in a later lesson. So, how do we know this? Well, if you've watched the video about the 2,400 year search for the atom, you'll know a little bit about how people like Bohr and Rutherford and even back to Democritus have come up with theories and evidence to support what is the structure of the atom. But what we're focusing on really here is this electron structure. And the way we really know about this electron structure is that we can excite an atom, and we can either do this using heat, like in a Bunsen burner flame, like in these cases here, or we can also do it in electrical energy. And this is done in a lot of lights. You might have heard of the orange street lights, which are sodium vapor street lights, so they have sodium in them. Neon lights, which are used in lots of shops and that sort of thing, have neon gas, and basically it's those neon atoms getting excited that produces that light. So back to what happens. When we excite one of these atoms, let me just bring up my pen and a good colour and the right size dot. When we excite one of these atoms through applying heat or something like that, or heat or electricity, it can jump from its energy level up into a higher energy level. So like that green arrow there shows, that atom or that electron has jumped up into a higher level, or what we call an excited state. So that's step 2 there. Then after that atom jumps into an excited state, normally it will fairly quickly relax back down, and when it relaxes back down, it'll lose that energy. So it's gained that energy, jumped into a higher level. That energy is, if you like, stored in that higher level, and then it jumps down to a higher level. And when it does that, we see light given off. So we use a little squiggly arrow to indicate light. So the electron then relaxes, releasing light, and that light has the amount of energy that corresponds to that energy gap between those levels. Now, each energy of light corresponds to a different colour. So when we think of a rainbow and the spectrum in a rainbow, so we think of the Roy Jabib, red, orange, yellow, green, blue, indigo, violet. What we're looking at there is different energies of light. So red is actually the lowest energy through to violet, which is the highest energy. And you might know the ultraviolet, which is the bit that's just past violet, which we can't see, but that's the stuff that burns our skin and gives us sunburn. So the colour of a light represents its energy. So what we also know is that each atom has a unique energy levels, and therefore gaps between these energy levels, and therefore will emit different colours of light. So if we heat up barium, we get this green light. If we heat up strontium, we get this very dark, intense red light. Calcium gives a more brighter brick type red. Sodium looks a bit yellow in this diagram, but it gives that more of a yellowy orange. Copper will give off a green colour light. And potassium, I usually call it lilac, or it's basically a purpley pink colour. So those are all telling us about the energy that's released. And if we go back to what I was saying before, these reds would be the lower energy, then the oranges, yellows, greens, and if you like this violet, the violety sort of purple colour would probably be the highest energy level gaps in the atom. So there we have what we need to know about the structure of the atom.